In this interview, we're meeting Professor Margaret Burnett from Oregon State University. She's focusing on end-user development, and today we'll talk about gender issues. So, are there any main gender issues we should consider?
Funny you should ask. I got interested in that very question with one of my PhD students at the time, Laura Beckwith, and we started looking into exactly that question starting in about 2003. And so at the time, we had no idea even how to begin. And so what we did is we took some old lab data that we had from various studies that we'd run on end-user development tools we were working on, and we had previously collected gender data, but we'd never analyzed it. And so we said, well, you know, if there are gender differences, what would we even look for? And so we had some high school researchers working with us at the time. So we had them create a lot of charts on one page for each individual user. And we had all kinds of stuff, you know, one feature, we had time on the x-axis and counts of feature usage on the y-axis, and we had all kinds of different colored lines for different sorts of features, and we were looking, and we spread them out all over the floor. And we were looking for everything, and sometimes we'd say, well, let's sort on everybody whose activity looks like an upside down V, and we'd do that. And another time we'd say, well, let's sort on everybody whose graph is mostly blue, and we'd do that. And sometimes when we'd sort, then we'd turn them over to find out the genders, and we'd say, oh my gosh, all these people are female. And so that caused us to start wondering about feature usage. And so at that point, Laura turned to the theory. And so she started reading a lot of literature about gender differences that had been reported in various psychology research efforts, in education, in communication. And so she read 5 different fields. And she read them always with that question right here in her head: what might we expect to see, given these theories, about differences in feature usage in deep problem-solving tasks on a computer, such as the kind of thing that end-user developers are engaged in. And when she did that, all of these very concrete hypotheses just dropped in her lap because theories had a lot to say that was directly pertinent to that question. So she ended up with something like 40 hypotheses, which is way too many to explore in a single PhD thesis. And so she picked a few of them. And so then we started investigating them directly with our own prototype, which is called Forms 3. And so in the context of debugging and testing, we started asking ourselves questions like, are there differences in the way males and females interact with the features we're providing them to help test and debug? And so the first thing that we found out is that statistically, males were much more likely to even approach some of the new features that we were installing in our environments. And so we found, and this was among non-computer science students, it was among college-age people in our university, but not people with significant computer science training. And over and over again, we found that males were more interested in exploring these new features than females. And we also found that males were more interested in genuinely engaging in these features to try to accomplish the tasks that we were putting in front of them, which were always about testing and debugging spreadsheets. And we also found that males were significantly more likely than females to tinker, which is to playfully explore with these features. And we also found that males were significantly more confident in their predictions of how well they would do with that kind of task than females. Now again, these differences that I'm telling you about are strictly statistical. So they're not true of every male or every female, but if you just rack up all the numbers together and look at the statistics, this is what we found. Mm-hmm. Well, so the way these things came together is very interesting. So one of the typical studies that we would do is we would take these spreadsheets that we had put together in our particular prototype, Forms 3, and we would have some bugs that we had seeded in these formulas that we'd harvested from other end users. And we'd tell them, you know, see if you can find anything wrong with these spreadsheets, and if you can, fix them. And so we always measured their computer confidence before they started. And then the males would use the features that we know to be good for testing and debugging, because many of our studies have shown that they're helpful overall. And then at the end of the studies, sometimes what we would find, and there's one in particular that I'm remembering right now, is that the number of errors that the males and females fixed were the same. However, the males used the features that we had provided them much more. And so the features that we provided them are very good at helping to solve these debugging problems. And yet the females were doing as well without them. But what the females were using instead was the familiar feature that most people know, which is editing formulas. Well, there's a problem with editing formulas, and that is it's dangerous. So although you can fix errors by doing that, you can also introduce them. The other tools, the ones that we provided to help debug errors, were not, you could not introduce new ones. You could only use them to further detect and find the right places to change. So the problem, the way this played out, is although the males and the females fixed an equal number of the errors, the females introduced significantly more. Well, why? Because they're using the only tool that can do that, and that's this dangerous formula editing, significantly more. So the laws of probability say they have to introduce more errors. So wouldn't it be nice if the females had stayed with the safer and more effective debugging tools? So at the end of the study, that's one of the questions we asked on our questionnaire, is if you didn't use this fancy new feature, why not? And the females were significantly more likely to say, because I thought it would take me too long to learn them. However, we also gave them all a comprehension test at the end of the experiment, and the males and the females scored the same on these tests, and it was quite an elaborate comprehension test too, with some easy questions and hard questions. So they scored equally the same, even though the males got a lot more practice with these features because they actually used them. So what we can see here, and of course, as with all our studies, the females were significantly less confident at the outset. So what we can see here is a picture emerging in which the females used the features less because they thought they wouldn't be good at them. They would have been good at them, at least according to the comprehension test, but they were putting themselves into this dangerous territory that resulted in them introducing new bugs that didn't get fixed simply by their own predictions that they wouldn't be good at them. So that's a problem. Another thing that we found is if you graph their confidence in computing against their usage of the features, for the females, we got this nice 45-degree line. So you have unconfident females that didn't want to use the new features, and confident females that did. For the males, however, we didn't get that line. So you have unconfident males and you have confident males, but it had no relationship with their willingness to explore the new features. And so the way that fits into this picture is that unfortunately you have the females down there near the bottom of the confidence scale, and so that was one of the main reasons why they weren't using the new features. So if we could do something that would, you don't want to artificially enhance their confidence, but if indeed they would be better at something than if they just don't realize that they could handle these features pretty well, and you can just present them in a way that makes it clear to them how well they would be able to do, then you might get more people up that scale making use of these new features. And as I said, for the males, although you have some low confidence males, it wasn't getting in their way of the features, so you don't have to solve it for males. So that's the first stage of what we found out just based in our own prototype, which was something we could manipulate and really change the features to see how things went.
Interesting. Did you look into other platforms?
Yes, we did. So after we had done those explorations in our Forms 3 prototype and done many of the experiments multiple ways and kept finding the same thing, then we started looking for those same phenomena in some other platforms. So we tried the same experiment in Excel, and in that case, we, instead of using college students, we instead used professionals in the workforce, not professional developers, but just people with jobs who use spreadsheets, and we used the Excel platform, and we found pretty much the same things. We also started looking at, I think I told you before about the work we're doing on intelligent assistants, and so every time we do a study to evaluate our progress there, we also pick up the gender data, and we find exactly the same phenomena there. So So we've looked at it now in three different platforms that involve end-user developers. Excel, Forms 3, and these intelligent assistants, actually more than one version of intelligent assistants, so I guess 4 or 5 platforms, and we always find the same thing. We've also looked at some other phenomena, but I'll just stick with those three, because I know those pretty well.
Okay, so does this also apply to professional developers?
Well, yes, as a matter of fact, it does. So the next thing that we did is we started saying, okay, I wonder if exactly these same things, the lower confidence, the less willingness to tinker, the less willingness to approach or engage in new features, might actually appear in people who do some sort of software development for a living. And so we were very lucky. We engaged in a company that had a lot of data that they had collected from other studies, and inside that company, it was a software development company, and so almost everybody who was there was engaged in some aspect of software development. There were people who were technical support people, people who do phone support, people who run around fixing various computers that are lying around. There were people who did things like design, and so those sort of kind of around the edges things. There were software test engineers who develop software whose sole goal is to test. There were the mainstream software developers whose goal is to create the new software. And there were managers of the people who create the new software. And we found exactly the same phenomena. We found less willingness to tinker by the females than the males, even the professional developers. Less interest in approaching new features in the platforms they were using among the females than the males. What did I say? Confidence?
You didn't mention confidence.
Okay, same thing. Yeah. Same thing, yeah. We found the same thing over and over and over again. And so when we were working with that company, we actually collected almost 3,000 users in one or another of these categories, and we always got the same results.
I know you're not a psychologist, but do you have any explanation?
Well, as I mentioned, when we started, we read from a number of different fields to try to understand what the theoretical underpinnings might be. And confidence is one of the areas that's implicated. The form of confidence that I'm talking about is called self-efficacy, and computer self-efficacy is specifically what we're talking about. And so the person who developed that theory, Bandura was his name, has quite a lot to say about how that can impact the way we behave. And so if your self-efficacy is low, then you're less likely to persevere if things get more difficult. You're less likely to kind of think outside the box and try different approaches. So it has lots of explanatory power about what's going on. But as I said, it's not the only factor, because it affected males and females differently. Another thing that's very well known about females is that they are notoriously more risk averse than males. And so here too, if the idea of messing around with some new feature, if you're afraid that you might mess it up, then there's obviously risk. And if you're highly risk averse, then that's another reason why you might not want to do it. And then, so those are two fields, two theories that come from psychology. Then if you turn to things like education, there's lots and lots of literature about gender differences in learning styles. And so if the way a software tool developer expects you to learn new features that they've put in there, say for example by tinkering, and if the learning style among the males and females is different, and the males are more likely to learn it that way than the females, then that's yet another thing in the way of them using it. So there's so many theories that participate in, that have something to say about why these things might be. Sometimes people try to get me to take a stand on whether I think it's biological or cultural, or genetic or whatever. And I've always said that I don't care. So I don't take a stand because I don't really think it's that important a question. My attitude is this. If you have a male and a female who works for you, and you give them some kind of software platform and a problem and say, solve it, I expect the answer from both of you at the end of the day, then what you need to do is make sure that you've given them a level playing field. So regardless of whether the tools fit to your own ability to solve problems comes from differences that are cultural or social or biological or whatever, regardless of it, still you need to give them both a tool that's conducive to them being the best they can be so that they can deliver the results equally well, because that's what you expect of them.
What are your recommendations to software developers who want to avoid these gender issues?
Okay, so I know a lot more about the problems than I know about the solutions, but we have been working on some solutions, and we have accumulated a list of 10 things that we call promising practices. And so these are things that software tool developers can take into account that try to make sure that their software isn't erecting some kind of a barrier that is statistically affecting more females than males. Now, I have to say, I sure wish our list of promising practices was longer, because we have very specific recommendations on it that only apply in specific situations. But we're working on making it longer, so this is a very active area of research for us right now. So I can give you an example of one of them, just to give you a flavor for them. So in some kinds of, especially problem-solving situations, a user is asked to make a judgment. So for example, with testing, you decide whether a value is right or it's wrong. And so that's a judgment, and it's a value judgment. It's not just a yes-no decision. It's a value judgment about the quality of the answer that you're seeing, and that in turn is a judgment on the quality of the formula that maybe somebody else wrote, and so you're kind of judging someone else's work. And you're also judging the computer, which obviously isn't a person, but many people have this sort of exalted opinions of computer's goodness, and so you're judging its work too. So in that kind of judgment situation, we recommend that you give the ability to have nuances on the judgments. So instead of yes, it's right, or no, it's wrong, we recommend 4 choices. Yes, it's right, maybe it's wrong, and it's wrong. And in fact, we've done this in a lab study. And what we found is that when we just had yes, it's right, and no, it's wrong, that the males would use the feature this many times, and the females would use the feature this many times. And then when we changed it to add the 4 choices, the nuances, maybe it's right, maybe it's wrong, what we found out is that the males used the feature even more, and so did the females. And so the gender gap was almost gone. And so when you think about it, this was no trade-off here. This was a barrier that was in the way of a number of females and also some males. And then when you really think about it, this is a richer form of communication. So if you're making judgments and you say, well, I'm not 100% sure, but I think so, and you have the ability to mark it in that special way, that enables you to come back and revisit the ones you weren't as sure of if you don't end up in a logical place after having built on these judgments. So it's a better feature from that perspective. And also, when you think about that one, well, the reason we put it in was because of the confidence issue. We wanted to make clear that you don't have to be 100% sure of yourself to still be able to get some use out of these features. And so that's one reason we did it. But then when we saw the results we had, we said, well, that's great, and we can explain at least part of it in terms of this confidence thing. But then we also thought about the way males and females are socialized to communicate. And so, it's kind of manly to take a stand and say, yes, it's right, and no, it's wrong. But females are socialized to be softer and more tentative in their communications of the value of other people's work. And so it may have also addressed their communication style better than the more dogmatic yes and no.
Does this gender issue have to do with the low participation of females in computer science?
Well, it's a very complicated question why we don't have that many females participating in computer science. So there's no one factor that can answer it. But we suspect that this could be one factor. And here's the scenario that we like to paint. Imagine that you are a middle school girl, maybe age 11 or 12. Imagine you're comfortable with computers. You've been using them for, drawing and chats and all kinds of social things. But now what you're being asked to use the computer to do is solve a problem. Maybe a math problem, some sort of logic problem, but you're using it for something real. It's not play. And so let's suppose that the features in that environment aren't great fits for your problem-solving style, your learning style, your communication style, whatever. And so as a result, you don't find it to be a great tool for helping you to think however it is you problem solve best. So let's say you make it through it, but it's just not great. So how likely are you to then say, I want to grow up to be a computer scientist? You're going to think, I hate this. So we think it's probably a contributing factor, but far from the only one.
Mm-hmm. So are female better at some parts of end-user development, you'd say?
I don't have any evidence for that, and I'd not be in a position to take a stand on it. I just think that we have to pay attention to what the data and the literature have told us about gender differences in problem-solving styles, learning styles, communication styles, and take those into account and make sure that our software can support that diversity of thought and problem-solving effort that exists out there, so that we aren't erecting barriers and narrowing the population of problem solvers, bright problem solvers, that our software can serve.
Thank you so much, Margaret, for explaining about the gender issues in relation to end-user development. And if you want to know more about end-user development, you should have a look at our other interviews with Margaret in cooperation with Christopher Scafidi. They have written a chapter also about end-user development at interactiondesign.org. And at our website you can also find many other interesting chapters, all written by thought leaders and inventors. Thank you so much for watching.